Hello, today I'm showing you my machine learning project traffic. So this is a CNN model that classifies and predicts German traffic signs. And I'm using TensorFlow and OpenCV in this project. They're both open source and free. First thing, I'm just going to load up the data in the command line. Here, going to the top here in the main. So what this load data function does, it basically traverses through all the image directories and subdirectories. And for each image, it extracts the pixels and then convert them into NumPy arrays. And similarly for labels, it extracts the number that the number of the subdirectory that the image is in. The next thing is after loading up the data, as you can see here, it's starting to train the model. We have a total of 10 epochs that I specified here. So that is what's doing wrong. It's going to go through all 10 of those. The interesting part here is actually the get model function. So this is where I set up and compile the neural network. I'm going to go down to the get model function here. So first, I'm setting up the convolutional layer. Have 32 filters and 3x3 kernel matrix. So what I found is 32 was a good number of filters. Increasing the number to 64 didn't improve the accuracy of the model, and a 2x2 kernel matrix wasn't good enough. The overall accuracy just stayed around 5%. So that's why I decided to use 3x3. And then one thing is that the general principle of modeling here is don't want a model to be too bulky. Just keeping it simple. So if I can get a good accuracy with 32 filters, that's just the number I'm gonna go with. And yeah, just making sure the accuracy is good. Next step here is polling. So I experimented with both max polling and average polling. What I found is average polling performed better than max polling in terms of the accuracy of the model. So that's what I decided to use. And then the pool size, I used a 2x2 for that. And then I applied convolution and max polling again using the same convolutional layer and average polling here. This is actually quite important. So this did help improve my model accuracy by quite a lot. The reason that some of the higher level features of these images can be extracted the second time around. So this is quite important. The next step is flattening out all the units. Now that I have the pixels, and then we can feed those into the neural network. For the neural network, I have a hidden layer with 128 units. And the activation function here that I use again is ReLU, the same as the ones above. And I also use dropout, which I also experimented with. So this value 0.5 is good. The range between 0.3 and 0.5 is about the same for me in terms of accuracy, so decided to use 0.5. And then lastly, we have the output layer where the number of units is equal to the number of categories of traffic signs. Now that the model is set up, we can compile it by having the optimizer function, loss function, and the metric to be accuracy. Now that the model is compiled, we can fit the model using training data and then test the model's performance using the test data. Right, so the model just finished running. So now we can have a look at what the output shows. So here we have a total of 10 epochs. You can see both the loss and the accuracy of each epoch. I'm just going to talk about accuracy here because that's the metric that I care about. So initially we have the accuracy about 39%, and then it really increased from the first epoch to the second epoch, went from 40 to like 71. And then after that, the accuracy did improve, but it kind of slowed down. After this point, you can see here, after maybe the sixth epoch, just starting to incrementally improve by like 1%, and then eventually it got to 97%. So think that was a good accuracy. Quite happy with it that it got to 97%. And this is one of the coolest projects I've done. So yeah, I hope you enjoy the video and let me know if you have any comments. And thanks for watching.